Hi everyone. So today I want to take a quick look at Atlantis, a simple yet powerful Terraform automation tool. So what Atlantis does is that it lets you run your Terraform operations like your Terraform plan or Terraform apply all from a single central location, and it incorporates your Terraform project that is hosted in a Git repository. So simply by creating a pull request, you can be able to plan out your Terraform infrastructure and also run the Terraform apply command. So this is obviously a great tool for teams, especially if you have multiple members all collaborating on a single Terraform project. Everything can be done from a centralized location, which is Terraform Git repository. Yeah, so you can see everything that is happening with the infrastructure all from within the Terraform project. Also helps avoid conflicts because pull requests have to be approved, applied, and then merged into the main project in the order in which they came. So what we're going to be doing today is installing Atlantis in a Kubernetes cluster and then integrating it with GitLab. So let's get started. Now, the first thing we're going to do is take a look at our Terraform project. So this is a simple Terraform project. What it does is just deploy Kubernetes node group into Proxmox. Yeah, so in the main.tf file, I just have a single resource here, and it's a Proxmox VM resource. So I'm just deploying 2 VMs into the Proxmox cluster, and I have all the details of the virtual machines like the operating system, the CPU, memory, disk drives, network, IP addressing. And then in the providers section, I'm just simply using the Proxmox provider. And then I am specifying an S3 backend, which we are going to be using for storing the Terraform state. Now, typically, if you're just running Terraform on your local machine, Terraform will store the current state of your infrastructure after you do a Terraform plan and Terraform apply directly on your local machine. This will be stored in a terraform.tf state file that lives at the root of your Terraform project. But obviously this is an issue, especially when it comes to Terraform projects that are being worked on by multiple members of your team. Each person cannot maintain their own version of the current deployed infrastructure on their own local machine. There will be some kind of conflict. So you need to have a single Terraform state file that everyone can reference. And Terraform uses this concept of Terraform backends, which basically helps you store the TF state file in a remote location that is accessible by everyone on your team. And there are a lot of backend options that you can use to store your Terraform state. In our case, we're going to be using S3 storage, and we're going to be using a local S3 storage solution, which is deployed in the cluster. So I have MinIO that is running in the cluster. So MinIO is basically S3 compatible object storage, and we can use it to store our TF state file. Yeah, so this is the basic configuration of the backend, the bucket name, the endpoint of the MinIO instance, and then of course the key where the actual Terraform state file is going to be stored in this particular bucket. So I have the access key and the secret access key, which are credentials for this S3 bucket, exported as environment variables on my local machine. So if I run Terraform init, I should be able to directly authenticate with this S3 bucket stored in MinIO. Okay, so let us go ahead and get our Terraform project ready. So the first thing I'm going to do is run Terraform init to go ahead and initialize our Terraform project. And actually immediately I see that I have a problem with the backend, so I have forgotten to export MinIO credentials, so I can go ahead and do that now. Okay, so here I'm exporting the AWS access key ID and AWS secret access key environment variables, which are going to store the credentials that are going to be used by Terraform to authenticate to this backend. So by default, Terraform looks for these AWS type environment variables to authenticate with any S3 storage. Yeah, so now that is done, we can go ahead and attempt to reinitialize our project. Okay, so now everything seems to be fine. Our project is now successfully initialized. Okay, so if I go ahead and run a Terraform plan, I should be able to see all the infrastructure that's going to be deployed from this Terraform project. And everything seems to be okay. I have no errors, just going to be deploying 2 VMs. And yeah, everything seems to be okay. So we can go ahead and apply that. So I can go ahead and run Terraform apply, and then deploy our infrastructure to Proxmox. And if I navigate over to the Proxmox web console, I can see that indeed VMs are being created here. Okay, so now we have successfully created our Terraform project and we have applied the infrastructure to Proxmox. Yeah, so now our Terraform project currently matches exactly what is deployed in our infrastructure. Yeah, so what we want to do is go ahead and push this to Git so that we can have a central repository for this particular project. Yeah, so I can go ahead and initialize a new Git repository in this project. So with that, I can now stage the current state of the project and then create an initial commit. So now our local Git repository is now ready to go. So what we need to do is go into GitLab and create the remote repository, which we can then push the local repository to. So I can head over now to GitLab and create a brand new project. Yeah, so this project is going to be called K8 Cluster Dev. And then I can go ahead and create the project. Yeah, so here I have some initial instructions on how to get set up with my existing local repository. Yeah, so down here under these instructions for push an existing folder, I've already actually initialized the Git repository and created the first commit. So all I have to do now is add this remote repository as a remote for my local repository. So I can go ahead and do that. Yeah, and once I've added the GitLab repository as a remote for our local repository, it is safe to go ahead and now push a brand new project into GitLab. So I can do that with the git push command and then set upstream to origin main. Yeah, and that's it. We have successfully pushed our brand new Terraform project to GitLab, and we can just go over here and refresh this page. So now we have our Terraform project successfully pushed into GitLab. So now we can go ahead and deploy Atlantis into the Kubernetes cluster. But before we do that, we need to have some prerequisites first. We need a way for Atlantis to authenticate and communicate with GitLab. So we're going to create a dedicated Atlantis user in GitLab. So to do that, we can go to the admin area, and under users, you can create a new Atlantis user. So you can actually use any user or any personal access token. But since Atlantis is going to be commenting on the pull requests using this token, all the comments will have the username of the owner of the token. Yeah, so to avoid confusion, it's better you create a dedicated Atlantis user. So I can go ahead and create this Atlantis user, and then I can just impersonate the user. And then if I go to edit profile, I can create a personal access token. So I can go ahead and create a new token. So I'll call this Atlantis. And then this requires API permissions. So you can go ahead and copy and save this personal token because we're going to use it later when we deploy Atlantis to Kubernetes. So another thing we need to do is generate a random string. And this is what is going to be used as a webhook secret. We're going to be creating a webhook inside GitLab. So this particular webhook is how GitLab is going to be notifying Atlantis of events that Atlantis is interested in. And these are mainly pull requests, comments, and pushes, which will basically trigger some kind of action on Atlantis. So I'll just generate a random string and then copy that and save that somewhere for later. Okay, so at this point, we're ready to deploy Atlantis in our Kubernetes cluster. And to do that, you can just create dedicated namespace for the Atlantis instance. So we can go ahead and add the Atlantis Helm repository. And then if you want to take a look at some of the default configuration for Atlantis, you can just simply fetch the default values file and just have a look through. If you need to change anything or if you need to run configurations for your particular Git repository, maybe it is GitHub and not GitLab, and then many other options are contained in the default values file. So to keep it simple, we're just going to create a different values file. Now this is going to contain just a few things that we wish to change from the default configuration. And the first section we're going to add is the GitLab section, which is going to describe basically the connection details of how we're going to be interacting and communicating with GitLab and all the repositories in GitLab. Yeah, so under this section, we're specifying the Atlantis user, which we have already created in GitLab, and the personal access token for the Atlantis user, the secret for the webhook that we also generated, and the host name for our GitLab instance. Yeah, so in my case, I'm using a self-hosted version of GitLab, so this is the domain name for the GitLab instance. So then I also set what repositories I wish to be managed by Atlantis. So you can set an allow list for the repositories. So anything inside this project, all the repositories in this project are going to be managed by Atlantis. So the next section is ingress. If you want to access your Atlantis instance using ingress or a domain name, you can set ingress enabled to true. Here I'm also specifying the ingress class that is going to be managing this particular ingress. I set the host as atlantis.homecube.io, and then I'm setting a couple of paths to expose. So the root path is just the web UI for Atlantis, and then the events path is the webhook endpoint for Atlantis. And also if you're using HTTPS and you're using secure certificates, you can define the secret name that holds the certificate for your domain name in the TLS section under secret name. Of course, this assumes that you're also going to be deploying this same secret in the same Atlantis namespace. Okay, so the next thing that is important for us to add is obviously the credentials that the Terraform binary inside of the Atlantis pod is going to be using to, run and perform all of these tasks, especially if it's going to be connecting to external infrastructure providers, like in our case, Proxmox. So we can load all the credentials that we need to be added into the pod using environment variables. Yeah, so here under the environment secrets section, I'm specifying all the secrets that contain all of our credentials. Yeah, so I'm going to create a Proxmox API credentials secret as well as a MinIO credentials secret for the S3 backend. Yeah, so for now that seems to be all the configuration that we're going to do for our Atlantis deployment. So before we can go ahead and actually deploy this Helm release, we need to make sure that we have first created all the secrets that are mentioned in the values file. So the first secret I'll create is the one containing the certificate file for the ingress. And then I can create the secret that contains the Proxmox API credentials. And then finally, I can also create the secret for the MinIO credentials so that our Terraform instance can authenticate with them backend to store the tf-state file. So now I can just run helm install to go ahead and deploy Atlantis into the Kubernetes cluster. Okay, so now when I run a kubectl get pods, I can see that we have a single Atlantis pod running. So if I do a kubectl get ingress, I should be able to see the ingress that has also been created. Okay, so now our Atlantis instance is up and running and we have successfully deployed it into the cluster. Okay, so now the next thing we need to do is create a webhook so that our GitLab project can send events over to Atlantis. So to do that, we need to go over to the Terraform project in GitLab, and then under settings and then webhooks, we can go ahead and create this webhook. So we can click add new webhook. So under URL, we can set the URL of our Atlantis instance, and we created an ingress for it, and we should add the events path at the end of the URL. Then the next thing we need to do is add the webhook secret. We generated this earlier and also used it in the deployment of Atlantis. And then we need to configure the triggers. What events are we going to be watching for that are going to trigger Atlantis into action? So here we can set push events, comments, as well as merge request events. So we can also do a test to ensure that our webhook has been created successfully. So under test, we can just try out a push test, and then we can see that the hook has executed successfully. Okay, so now let us recap. We have created a Terraform project, we have applied the changes, and our infrastructure is up and running, and we have also pushed this to GitLab. We have also deployed Atlantis in a Kubernetes cluster and connected it successfully to GitLab. So now it's time to see Atlantis in action and how exactly it works. So to do this, I'm going to create a pull request. Yeah, but before anyone else can create a pull request, we need to make sure that they are all invited into the project and that they have access to the project. So I can just go over to our K8s cluster dev project and then manage the members of this project. So I can add some additional members to the project. I can add just a couple of members as developers. Yeah, so now let us choose one of these users and just have them create a pull request for our project. So if I go into the admin area and then under users, I can choose one of the users and then impersonate this user. So under the K8s cluster dev project, assuming this user wants to make some changes to our current infrastructure. So I can go ahead and make those changes. So I can open up the project in a web IDE. So let's assume they want to change the count of the node group to 3 VMs instead of 2 VMs. So I can go ahead and set that to 3 and then add a commit for this. So I've created a new commit, which is set VM count to 3. So I want to go ahead and commit this to a new branch. So I'll just leave the default name of the branch and then press enter. And then I can go ahead and create a pull request. Yeah, so down here it says the changes have been committed successfully, and I have the option to go ahead and create a pull request. So I can just click on that and a new merge request or pull request has been created. So I can go ahead and create merge request. So another user has proposed some changes, created the changes under a merge request, and then they have submitted this to the GitLab project. So Atlantis will now automatically spring into action. As you can see here, we already have some activity under the pull request. So Atlantis has gone ahead and done a Terraform apply. And we have the output of this Terraform apply. So we can just see actually the output of what is going to be changing in our infrastructure. So in addition to the VMs, the 2 VMs that we already have, we're going to be adding an additional VM. So everything has passed successfully. We have not introduced any errors into our Terraform project. So everything is looking fine. The developer can go ahead and apply the changes to the infrastructure. And you can do this directly from the pull request by adding a single comment. And you can see some of the examples given here. You can do Atlantis apply, Atlantis unlock, Atlantis plan. So let's go ahead and do an Atlantis apply and add the comment. So you can see changes to the infrastructure are already taking place. If I go over to our Proxmox dashboard, we can see that we have added an additional VM to our Kubernetes node group. Yeah, so Atlantis has gone ahead and run Terraform apply on our infrastructure. And once that is successfully completed, it will add a comment onto the merge request with the output of the Terraform apply command. So we can look at the output of what has been taking place in the background. So our Proxmox infrastructure has been modified, and you can see what has happened and the changes in the resources that we have applied. Yeah, so you can already see the benefits of using Atlantis. We're seeing everything happening within the Git repository. And no one needs to go off into separate machines and do Terraform apply and then have some kind of communication over chat to know who is about to make what change. So everything is being done in a centralized location, and every member of the team can see what is happening. We can have discussions about what is happening, and we can the people that have the privileges on the project can also give the relevant approvals before any changes of the infrastructure takes place. So another thing that is good with Atlantis is that it helps with conflicts. So imagine we have at this moment someone else attempting to make a change to the infrastructure. So under users, I can just go ahead and impersonate another user. So this user also has access to the K8s cluster dev project. So assuming they want to make some changes to the project as well. So let's say, in fact, instead of 3 VMs, we needed a total of 4 actual VMs. So I'm setting the count to 4. So I can go ahead and set a new commit for these changes and then add this commit into a new branch and then go ahead and create the merge request as well. So the merge request has also been created here, set VM count to 4. So I can go ahead and click create merge request. So immediately you can see that Atlantis has attempted to run a Terraform plan on this new merge request, but it has failed. The plan has failed because it says that this project is currently locked by an unapplied plan from pull request number 1. So the earlier pull request that's still currently in progress, although the infrastructure changes have been applied, has not yet been merged into the main branch. Yeah, so no additional changes are going to be made until that particular pull request has been merged and closed. So this is how we're able to avoid conflicting with each other. Everyone is supposed to wait in line with their changes, and then this gives us opportunity to discuss what changes are going to be made, and this keeps the integrity of infrastructure intact. It keeps us from making catastrophic changes to our infrastructure due to some kind of miscommunication. Okay, so let's go ahead and resolve this. I can stop impersonating this user, then just go over into the project, K8s cluster dev project, and then just have a look at the merge request. So I have this merge request here that has been applied, and it is now ready to merge. So you can just go ahead and click merge. So the new branch has been successfully merged back into the main branch. So it should be safe to proceed with the second merge request. So we just have a single merge request remaining. Yeah, so now when we look at this merge request, we see that we have some errors arising due to some conflicts. This is because the two different branches were all basically making changes around the same thing, the VM count. So before we can proceed, we need to resolve the conflicts. So we can just choose which one we need to go with. So since we want to set our changes, we want to increase the VM count once more to 4 VMs instead of 3. We can select use hours and then commit the changes to the source branch. Yeah, so after resolve the conflict, this new pull request should be ready to merge. And then Atlantis has also gone ahead and run a Terraform plan. So we're also seeing what is going to change to the infrastructure. We have a 4th VM that is going to be added to our infrastructure as a result of this new pull request. So that is the power of Atlantis. It's a very simple tool, but yet very powerful. It has the ability to transform basically your Terraform workflow. So you can look at the documentation to see all of the available configuration options. There's a lot that can be done in addition to what I've just demoed here. So once again, thank you very much for watching. I hope this quick demo is helpful for you in some kind of way. So don't forget to like the video, subscribe, and I'll see you in the next one.